Representation includes 6 parts. Firstly, the interharmonics in PV system are included. Secondly, the mathematical module of interharmonics is derived, and some influencing factors of interharmonics are analyzed. Then, a real-time calculation method of interharmonics amplitude is included. In addition, an interharmonics suppression method based on module predictive control is proposed. And finally, in order to improve the surprising factor of interharmonics, its specific frequency and adaptive parameter adjustment mechanism is proposed. Okay, let's see what is interharmonics. Interharmonics are components whose frequency is non-integer multiple of the fundamental frequency. Due to the inherent characteristics of solar energy and the control characteristic of the PV grid-connected system, the PV output shows strong randomness and volatility. In addition, the large-scale input of nonlinear power electronics devices and the application of the MPPT algorithm will bring complex harmonics and interharmonics problems to the grid. Interharmonics may result in harmonics in the sub-synchronous frequency band interacting with mechanical oscillations of the neighboring generator shift system, thereby including sub-synchronous oscillations in the system, affecting the normal operation of relay protection equipment, leading to its forced operation, including a visual reaction of the human ear to the lamps and the lanterns and the fixed phenomenon, causing a decrease in system power factor and affecting the quality of grid-connected power. Compared with harmonics, interharmonics are more widely distributed, more complex to analyze, and more serious in harmonic. The research of harmonics suppression strategy of PV grid connected system is a key to improve the quality of grid connected power, and it has a certain engineering value. So how specifically are interharmonics created? A mathematical module of the interharmonic current of the PV connected system is first established based on establishing the transform function of the PV connected system. The correct equation of the PV arrow is linearized, and its output current is decoupled into a DC component and an AC component, GVDC, which is only determined by the parameter of the PV array and the DC voltage. Then, by the derivation of the transform function, we can get the block diagram of the transform function of the D-axis current. Next, we need to analyze the input perturbations. The 3-point oscillation characteristic of the dV voltage is extended into a Fourier series, and the expression of the output current in the D-axis can be obtained. The results show that the grid connected current of the PV grid connected the system will contain interharmonic components with angular frequency. When the DC voltage combine output from the MPPT X, the MPPT exhibits the characteristics of 3-point oscillation with angular frequency near the maximum power point. System parameters such as DC capacitance likewise affect interharmonics. In addition, the influence of the environmental factor is also analyzed. The change of radiation and ambient temperature has little effect on the amplitude of the interharmonic current, but will change the magnitude of the fundamental current, then affect the relative current of the effective current. In order to quantitatively analyze the specific current of the harmonics at each frequency, it is necessary to calculate them accurately through the mathematical module of the interharmonic current of PV grid connected system. The frequency of interharmonic current can be obtained, and then the real-time calculator method of interharmonic current attitude based on the triangular function oscillating theorem is deduced. Firstly, by the defining the harmonics resulting frequency, and then reconstructing the output current of the harmonic content harmonics into a function system with the function of Fr as a base, so as to realize the real-time calculator of its amplitude based on the trigonometric function theorem. An harmonic suppression method based on module predictive control is proposed in the paper. This method is based on the vector control of the inverter. For adopted two-level inverter, the voltage vectors corresponding to all its switching states are shown in the figure. As a multiple objective optimization problem, it is very important to exploit the cost function. So in this paper, we built the cost function to calculate the harmonics. The control block diagram of the control strategy is shown here. Step 1, sampling and receiving current command, and then calculate the current predicted value, and then calculate the cost function. Finally, the rolling optimization is realized by finding the switch state that minimizes the value of the cost function. In order to verify the effectiveness of the proposed control system, we build a a PV simulation system platform. The table shows the system parameter setting. Okay, the figure illustrates that the simulated waveform exploring classic module predictive control, and the A phases current spectrum shows that the interharmonics with larger amplitude are distributed. When the default parameters are used, the proposed control result is shown in the figure on the right. We can see the result is it can be seen that the amplitude of inharmonics current at each frequency. The amplitude of the interharmonics current at each frequency is suppressed to a considerable level with the proposed control strategy. In order to strengthen the suppression effect of specific inharmonics, the secondary interharmonics coefficient at 35 Hz and the 65 Hz are adjusted using the parameter adaptive adjustment. The stability in harmonics rejection rate at 35 Hz and 65 Hz are increased to 31% and 34% respectively, which is an increase of up to 26%. Okay, finally, let's make a conclusion. Through analysis and experiment, we get some conclusion. First, harmonics in PV system are influenced by MPPT parameters, topology parameters, and environment parameters. In order to compared to SRC, the proposed method doesn't include the new inharmonic and have better suppression. Compared to SRC, the proposed method doesn't include the new current and have better suppression. Okay, that's all. Thanks for attention.